You have a scar from an old injury. The skin has healed, the tissue is repaired, but sometimes you can still feel an echo of the original event, a ghost of an ache. It's easy to dismiss this as purely psychological, a simple memory trick. But what if the memory isn't just in your mind? What if your nerves themselves, deep in your spinal cord, physically remember the injury? The truth is that the experience of pain fundamentally rewires the system that reports it. It leaves behind a biological trace, a physical memory that can last long after the wound has closed. When you first get injured, say a simple paper cut, the damaged cells don't suffer in silence. They scream for help by releasing a chemical cocktail into their surroundings, a sort of inflammatory soup. This soup is filled with molecules like prostaglandins and bradykinin, which do two things. First, they call immune cells to the area to begin repairs. Second, they wash over the local pain-sensing nerve endings, called nociceptors. This chemical bath makes the nociceptors incredibly sensitive, lowering the threshold required for them to fire a pain signal. This is called peripheral sensitization. It's why a sunburned back hurts from the slightest touch of a t-shirt. That initial, amplified signal doesn't travel directly to your brain. It first arrives at a critical processing hub in your spinal cord known as the dorsal horn. Think of it as a gatekeeper. Here, the signal from the periphery is handed off from one neuron to another. Under normal circumstances, the gatekeeper relays the message accurately. But a strong, relentless barrage of pain signals can overwhelm this system. The constant stimulation changes the very structure of the synapse in the dorsal horn. The receiving neuron becomes more receptive, sprouting more ears in the form of extra receptors. This is central sensitization. The gatekeeper is now an amplifier. This structural change isn't magic. It's driven by a specific molecule. When the neuron in the spinal cord is bombarded with signals, its internal environment floods with calcium ions. This calcium flood activates an enzyme called calcium/calmodulin-dependent protein kinase 2, or CAMK2. CAMK2 is a remarkable molecular machine. Once activated, it can effectively switch itself on and stay on long after the initial calcium signal has faded. It's a form of molecular memory. The on-calcium K2 then goes to work, modifying the pain receptors on the neuron surface, making them far more efficient at passing along a signal. It has physically etched the memory of pain into the cell's hardware. With the CAMK2 switch flipped and the neurons physically altered, the system is no longer reporting on the present state of the body. It is now reporting on its memory of a past injury. The pain pathway has become its own echo chamber. A signal that should be a whisper, like the gentle pressure from your clothes, now enters this sensitized system. The modified neurons in the dorsal horn amplify it into a shout. This is a phenomenon known as allodynia, where non-painful stimuli are perceived as painful. The system is no longer a reliable messenger. It is a biased storyteller, constantly retelling the story of the worst pain it remembers. This molecular memory mechanism provides a chilling insight into chronic pain syndromes. In conditions like fibromyalgia or complex regional pain syndrome, the pain is not coming from an ongoing injury out in the body. Instead, the pain memory system itself has become the disease. The CAMK2 switches are locked in the on position, creating a self-sustaining loop of pain perception. The brain receives constant, amplified pain signals from a spinal cord that is stuck remembering an old trauma, or perhaps a trauma that never even had a clear origin. The memory of pain has become indistinguishable from pain itself. The molecule didn't just record the event, it became the event.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.